Good afternoon and good morning to everyone attending today. Today is day 2 of the Azure for AWS edition series, webcast series that we're offering. And today we're going to review the developed solutions with Azure Storage. I'm going to introduce you with your presenter today, Mr. Rafiq Wayani. Rafiq, we ask you to go ahead and take it away.
Hey guys, how are you? It's a pleasure to see you again. Today, I'm going to talk about a topic that's near and dear to me. It's talking about storage. It's such a big deal if any of you have worked with storage and dealt with storage in different realms. No matter what aspect of technology you work with, whether it has to do with front end or back end or development or security or analytics or anything in between, storage is a big piece of the puzzle and big piece of the equation. It affects what you do directly or indirectly in one way, shape, or form. Today, we're going to be talking about Cosmos DB. That's Azure's essentially NoSQL solution. Amazing. And we're then going to be talking about blob storage. And finally, we're going to end the session with me demonstrating and showing ARM templates or Azure Resource Manager templates to you. Let me ask you something. All of you have been involved with dealing with and working with databases in your life in one way, shape, or form. The fact of the matter is that databases have been a part of what we do for so long that we tend to forget how much they impact what we do. What I want to do is I want to show you exactly what Cosmos DB is all about and how it relates to and how it's going to make your life a heck of a lot simpler in many ways. You may have been dealing with a relational database management system your whole life. It's very possible, where you're dealing with transactions all the time. You know, everything isn't meant to be stored and manipulated by a Rdbms. What I mean by that is if you really need global replication, global access, Rdbms is really not your best option. For that purpose, Cosmos DB comes into the picture. Now, Cosmos DB is a fully managed NoSQL environment, not only SQL environment. It has single-digit millisecond response time and automatic and instant scalability, and it guarantees speed at any scale. When you think about a relational database management system, what comes to mind for you? Can you imagine scaling a Rdbms out? And what I mean by scaling out is adding more databases across. So if these are connected Rdbms environments, and maybe this one exists in the West, this one exists in the Midwest, this one exists in the Southwest, this one exists inside of the East, and you wanted to replicate this across an Rdbms environment, that's a very, very difficult ask because Rdbms's are ideal for, well, they're meant to be scaled up. In other words, if you add more RAM, more disk, more processor, more networking resources on that simple, single relational database management environment, your SQL server, for example, if you wanted to add more RAM, more processing power, more networking resources, and more disk resources on this single node, Rdbms is perfect for that. As soon as you want to scale out, in other words, you want to make it possible for Los Angeles to communicate very quickly with users that are in Miami, in Denver, in Houston, in New York, in Boston, in Dallas, in Phoenix, that's a difficult ask if you wanted to do that rapidly. For that purpose, NoSQL is perfect for that purpose, because it is designed, NoSQL is designed to be scaled out really rapidly. Another thing you want to keep in mind here, some of the benefits associated with NoSQL is that there is a very high throughput. When you are communicating with your map on your phone, you know what I mean by map? Of course you do. GPS, when you're going from point A to point B. If I'm traveling from Atlanta to Tampa, I need some real-time traffic data to tell me what's happening. Think about that for a minute. Real-time traffic data, right? That's what's an overlay on top of directions. I know how to get from Atlanta to Tampa. What I don't know is what the traffic is like right now, how long it will take me to get there right now, what kind of construction, detours, weather, accidents, and so on that are in place at the moment. I can take a look at my map, take a look at the amount of time it's going to take me to get there right now, and make a decision based on the information I have at my fingertips. That overlay is dynamic. Weather information is dynamic. Accidents, along with route detours and construction, those are all dynamic pieces of information that are coming in on top of the map. And it has to come in with very high throughput from everywhere. Now, who says I'm going to go from Atlanta to Tampa? I can travel west. I can travel from Atlanta to somewhere in Texas, somewhere in Denver, perhaps, or somewhere in Utah, or wherever, really. So I need the data in coming in a very rapid way. That's where the millisecond response time, single digit millisecond response time comes into the picture. I'm sure you have looked at your map and where you're traveling and you've said, well, this is taking too long. This is taking too long. I don't see an update. That happens rarely. That's really what I was trying to say. As you're driving, those updates need to come in very, very rapidly. In addition to that, the schema of a NoSQL environment is indeed very, very fluid. And what I mean by schema is when you think about a relational database management system and you think about an invoice, if I tell you an invoice, right? I have an invoice row. Some things come to your mind that are very structured. Customer name, invoice number, a total, products, shipping, tax, right? Invoice is coming to mind. Shipping address, billing address, invoice is coming to mind. That is a very rigid structure. That's not something that NoSQL is designed for. It's not designed for relationships, if you will, the way relational database management systems are. NoSQL is great for a fluid schema. So the example that I was giving you with a map, with a GPS, with weather and construction and accidents and route detours coming in, those are coming in from different sources and different kinds of data. The schema associated with weather is different than the schema associated with construction, than that of accidents, than that of detours, because they're coming from different places. So the fluid schema, all on top of the map, if you will, that's giving me directions on where I'm supposed to go. In addition to that, something you don't even notice, well, you do notice, you get a red line where the traffic slows down, a yellow or amber line where the traffic is slow, red when it's like almost stopped, and green when traffic is good. I'm sure you've seen that. That is also an overlay. It has to do dynamic analytics, real-time dynamic analytics, to figure out how to give you the red line, the amber line, the green line, so that you can see how well the traffic is flowing. You can see where the slowdowns are. So all of that information is coming in dynamically, and it's coming in from all over the nation, from different sources. So high throughput, fluid schema, and microservices are great for that. Microservices, serverless architectures. The functions, for example, Azure Functions can take advantage of, the data has to go somewhere, can take advantage of Cosmos DB. So if you take a look at this little insight here, right there, The one that says if you want consistency and availability, relational database management system is great for that. But if you want availability and partition tolerance, NoSQL is perfect for that. Now, partition tolerance is where I have kind of represented this. So database in the NoSQL environment has containers. These containers have logical partitions. In this particular instance, you've got logical partitions. You can have different keys associated with each logical partition. Airport as a key, city as a key in the other place. And then within the keys, within the partition keys, you have items. And there can be as many items as you need. The physical partition is internally managed by Cosmos DB. You don't have to worry about that at all. You end up creating the container. You end up creating the container, and then you end up communicating or adding the items. In the container, you specify what your key is going to be. Now, think of this for a minute. If you are going to be storing invoicing information, yeah, or customer information, or you're storing telemetry information associated with your IoT, your internet, your Internet of Things, right? Your watch, your health, your how much you're walking, you're breathing, you're sleeping, your HVAC system, who knows what, something coming from your fridge, something coming from your microwave, or how many people are entering and exiting your building, how the lights are dealt with, how many lights are on and off, and which offices are acquiring things, really whatever the case may be, so that you can gather analytics. This is another great thing. Gathering real-time analytics is perfect for NoSQL, real-time. Historical analytics are great for relational database management system. I'm going to go back to the example I was giving you of a map, of a GPS, of traffic. If I tell you, hey, you can go from Atlanta to Tampa using this route, and I'm going to say just go south. You might say, okay, I'm going to go south on 95 and I'll get there. But wouldn't it be great if I was able to tell you that right now, this is how long it will take you to get there, real time, right now. So NoSQL would be able to provide you with the right now, I'll just say RT for real time, right? And a relational database management system in that same scenario would be able to tell you that in the last 5 years or in the last 16 weeks on a Monday afternoon, it has taken this long to get from Atlanta to Tampa. And as a result, statistically, probability is very high that it's going to take you just as long within this range to get from Atlanta to Tampa. It's going to use not real time at all. It's going to use historical information to accomplish that task. Historical information is not ideal for many real-time analytics in GPS, for example, mapping, for example, routing information of traffic and such. You need that in real time. It's great that it took somebody 2 hours or 5 hours to get someplace 3 weeks ago, but I'm not interested in 3 weeks ago. I'm interested in right now. So you have this NoSQL environment that is great for high throughput. This is where remember, single digit millisecond response. Again, the example that I was giving you of a map, that's really what you need, a single digit millisecond response. When's the last time you looked at your phone and you looked at the map and you were shaking it going, come on, where's the update? I need to know if, and you know, your map and your GPS reroutes as well. If you tell it to, it offers you suggestions along the way, letting you know that this route is faster. And if you take this route, you will save 10 minutes, 8 minutes. You've all seen that. And if you make a wrong turn, it reroutes. So all of those things is real time. You cannot get historical information when you're driving. It wouldn't be really useful. Okay, so that's the one big reason behind the use of Cosmos DB. Let me show you something else that I think you will appreciate in terms of what you get with Cosmos. See here? All right. Okay, so right here, if you take a look at SQL Server, the SQL Server environment, the scale out architecture of SQL Server. The scale out environment simply says that I've got read partitions in other places. So if I am located, for example, in Los Angeles, LAX, I will have read partitions, for example, maybe in San Francisco, maybe in San Diego, right? And maybe in Fremont, all in California, if you will. But those are all read replicas, right? So read replicas. So the application communicates with the listener, and the usually the read write is taking place in one location. So in this instance, as I was giving you my example, the read write is taking place in LA, and every other place is doing read only. And the listener is designed to, well, essentially allow you to read from the other locations, the read replicas, and the transactions are moved to read-only replicas from the read-write replica. That's really how generally, not always, but generally how things are in a RDBMS. In Cosmos, however, you have the application communicating with an API. API communicates with a container, and as I was telling you before, container is the one that has the logical partitions, and that logical partitions are based on a key, whether it is a city or an ID, or it has to do with an airport, or it has to do with whatever, meats. If you're storing meats, maybe it's going to be a whole bunch of meat, your fish and your poultry and your steak and your, whatever the case is, chicken. However you want to store logical partitions. So here you've got Europe, you've got Australia, and you've got US in this particular instance. And you've got, in this case, 3 nodes. And depending on the node in the location, you've got your container with a partition key that is defined that grabs the information on the replica. You can have node 1 in Europe that's a read-write, for example, and you can have a node 3 in US that's a read-write. You notice that? You notice the way this thing is sitting? What I'm saying is you can design the architecture for whatever you want it to be so that it is a fast read, fast write, globally replicated. So Cosmos DB, global replication, sub-second response times, millisecond, single-digit millisecond response times. All right, so it is guaranteed speed at any scale. Simplifying application development, it is definitely mission critical ready. Yes, mission critical ready. Your GPS on the map that I was giving you, and I was telling you an example of, that is mission critical, because eventually, if it wasn't giving the right information, people will stop using it, stop relying on it, and of course, the rest is history in terms of its purpose. It's fully managed and it's very, very cost effective. Let me show you a couple of other interesting things here. Because you are not really utilizing the transactional aspect of a database, you are not really doing that. Some options that exist inside of Cosmos DB, oops, some options that exist on top of Cosmos DB. Let me give you that example. Let's see here. And here are, when you begin to create a Cosmos DB, as soon as you say you want a Cosmos DB, you are asked which API suits you best. API, yes, API. You're developing across this. You want to do analytics, you want to do write, you want to do reads, you want to do it really, really quickly. So you can have the SQL-based API. That's one thing. Okay, this is API that's supported working with documents. And documents, you see this documents, working with documents. In NoSQL speak, instead of using the words tables and rows, you use the terms collections and documents. Collections and documents. Your social media account is an example of a collection. And every post on social media that you put, is a document. Why is it a collection? Because it is not related to anything. Your social media account is not related to some other social media account in the manner that a products table may be related to an inventory table. Sales table related to a products table, sales table related to a customers table. This right here, sales, products, customers, this relationship, if you will, does not exist in the case of NoSQL or collections and documents. The relationship model is not there. It's very different. The purpose is very different. That's why it said there's a SQL language inside of, it says Core SQL API that lets you work with documents. Every post you make is a document, not a row. A row implies a strict, rigid schema. Invoice ID, right? Invoice ID, invoice date, customer ID, product ID, shipping address, billing address, shipping amount, shipping tax, right? Rigid. That's not the case with your post or a document, as I was describing, inside of your social media account. Your document is independent of any other document. Your post that you're posting right now is independent of any other post. It is not related to anything. So in your post, you may have a text, something that you're typing. You may share an image. You may share an emoji. You may choose to upload a video. You may choose to upload audio. You may choose to use someone else's video. You may choose to have a URL or all of those things. And every single document, every single post is different. What I post right now is not related to what I posted earlier today. It's not the same thing as relating a products table to a sales table to a customer table. That's not how this works. So keep that in mind. Whenever you think about NoSQL, you're thinking about globally spread, fast access, real-time data, and you're not thinking about relationships. You're thinking about accessibility. You're not thinking about scaling up. You're thinking about scaling out, right? So SQL is one of the APIs that you can work with. There's also Mongodb, right? Mongodb apps that are basically written out for Mongo, that you can have your MongoDB workloads in there. Okay. There's Cassandra. Cassandra is also NoSQL environment. Cassandra has its own query language called CQL. Right. So there's Cassandra that you can use when you provision your Cosmos API. You can also have an Azure table. It's just table storage. If you don't want to rewrite your application using SQL API, you can use Azure table storage. It works kind of like tables with the strict structure, if you will. Then there's Gremlin, which is a graphing database. This is awesome. I don't know if you've worked with graphing databases. They're really kind of cool. Think of it this way. If you are trying to figure out that you are in a conference with me, Rafiq, right? If somebody's trying to do analysis and find out where Rafiq was on this day and this time, and how many people were listening to Rafiq in a traditional relational database management environment, how long do you think that would take? How many relationships of data would that be before somebody figured out that, hey, Tom or Bill or Jane knows Rafiq because of this time on this day, because of this schedule, because of this service, because of this webinar that was sponsored by Microsoft. They were listening to Rafiq. That's how they know him. That's not easy to do when you're looking at a relational database. In a graphing example, everything can start with me in the center, for example, and then it can go out and find out my calendar, find out what I was doing today, my Azure conference, find out the attendees in the Azure conference, people that were attending it, and it can make this relationship essentially very quickly. It can say that Rafiq knows Tom or Bill or Jane or Sandy because at this calendar item, he was providing this Azure webinar and this individual was attending it, and that's the relationship Rafiq has with this person. Okay, So that is a graphing example. Of course, I'm doing it very simply. You can look this up. It can be very, very important in detecting fraud from the perspective of banks. Think about it that way. Let me give you another example of that. You know, my credit card from my bank, my credit card is used all over the place, and it's used. I have a couple of signers, my kids, my wife, they use it everywhere. The bank has to figure out, without bothering me or my family, the authorized people, it has to figure out, these transactions have to figure out if it is a fraudulent transaction or not. It bases that on pattern, right? Bases that on real-time pattern. I'm doing it all over the country and all over the world. So without the graphing capability of trying to figure out if it's fraudulent or valid, otherwise I would be prompted with calls all the time. Do you recall 10 plus years ago, I was bothered by my bank when I went out of state, when I went out of city, and it saw transactions in another city. They would call me, decline the transaction, and ask me, is this really yours, Rafiq? That was bothersome, and I hated it. I did it. I understood why, but I hated it. Well, graphing makes that process much easier and much more real time. NoSQL makes that happen, right? And then there's, so you can choose Postgres API that is very much JSON-B or binary JSON features, right? Has rich indexing and other extensions associated with the Cosmos DB. Now, the one that I have built, I've got SQL that I'm building it off of. Once you have that, I want to show you something else. Once you have that, you essentially build out and you specify your account, right? When you're building out the database, you are specifying that what your subscription is, you specify the name of the subscription, you specify the account name, you specify the location where you want it. Now you can have this provision throughput. Remember, in my discussion with you yesterday, if you were here, I spoke to you about Azure compute units. And I said Azure uses compute units so that it can abstract away the RAM processor disk network, and it uses compute units with respect of some, if you will, relativity is really what it's using as a gauge, giving you a metric that you can gauge the relative performance of a given Azure machine or an Azure environment when we were working with service plans. So in the case of provision throughput inside of Cosmos DB, you're using resource units or RUs. Now, RUs are also a relative gauge on what kind of resource units you're given. Think of it this way. Resource units, right? Think of it this way. If you think about row size, if you think about row size, and you think about network throughput, actually bandwidth or the network pipe, and then you think about your users or applications that are going to be hitting your environment, and then you think about the kinds of transactions or the kinds of things that will be performed, your normal, if you will, CRUD operations, create, read, update, delete, and perhaps search as well. Your normal operations, isn't that going to depend on the row size, how long it takes to insert a row, create a row, right? Read a row, update a row, delete a row, search for a row. Isn't that going to depend on the size of the row and the network bandwidth and the number of users hitting it and a bunch of other metrics? Isn't that true? How the thing is scaled where you are. Resource units are supposed to abstract away the complexity. To give you an example, one resource unit may be equal to 1K of reading read row. So 1K row read once is one resource unit. But that range can change drastically if you're dealing with larger rows or smaller rows, different bandwidths. If you're doing an update or delete or a search, how much data is coming back and a bunch of other stuff. So I, the user, and what I mean by user is developer, I don't want to deal with how fast or how slow or does this work or does this not work. I can use a relative measure of resource units to figure out if it is indeed what I want. Okay, so here's applying a free tier discount to this particular instance. And look right over here, it tells you that you're going to get 1,000 resource units and 25 gigs of storage for a free account. Right, 1,000 resource units, relative, okay? And then I can also limit the throughput if I so choose. I didn't, but you can. Okay? Also, I want to tell you about this whole, because it needs to be understood very clearly, this provision throughput, the difference between provision throughput and serverless. Okay? So there's a comparison of provision throughput and serverless. There we go. All right. So when you're provisioning a Cosmos DB, you have the option of selecting provision throughput and serverless. Okay. So provision throughput is workloads that sustain traffic requiring predictable performance. Predictable performance. So if you need real-time, near real-time performance, maybe do that. Intermittent or unpredictable or low or average performance serverless would be ideal for. Now, everything doesn't need to be immediately updated, and maybe you don't need immediate predictable performance. That sounds kind of funny, doesn't it? Let me explain to you what I'm talking about. When you are getting weather reports, or you're getting stock information, or you're getting sports information, sports facts and what happened on the game, if you're looking at that on your phone, do you really need weather right now? Or is 2 or 3 minutes, 4 or 5 minutes okay? Right? Do you really need to know how well the some team is doing right now? If you're just looking at the numbers, you really need it right now? A few minutes delay is okay. Depending on what time you're looking at that data and where you're looking at it from and what kind of bandwidth you have. If you're connected utilizing, of course, high speed plugged in speed, or if you're on a 4G, 5G network, if you're on Wi-Fi, if you're in your car, if you're on a plane, right? Maybe you don't need that data immediately. So depending on what the purpose is, you're going to decide the throughput. You're going to decide provisioned or serverless. And then it's talking about how it works. It's talking about resource units. Okay, so every second resource unit that makes it available, dealing with that in terms of provisioned. And then geo distribution. Okay, so this is available for unlimited number of Azure regions. Okay, serverless accounts can only run in one Azure region. Another difference, if you're thinking about production, enterprise, tier 1 application, provision throughput is what you want. Maximum storage per container is unlimited here is 50 gig container. Remember container? Physical container, we're talking about logical container. The database is split up into containers, right? Container 1, container 2, and then within the container you have a key. Within a container you have a key, and you specify if the key is going to be some ID, it's going to be some city, and that's how you're basing it. And then performance, you have less than 10 millisecond latency here, right? As you can see on the reads and writes are covered by whatever service level agreement you have agreed to when you provisioned this. Okay, and here you have less than 10 millisecond for reads and less than 30 millisecond for writes that are configured by your service level agreement. Okay, and then the billing model. Billing is done on a per hour basis for resource units. All right, that's provision regardless of how many resource units you've consumed. Regardless of how many resource units that you've consumed. Okay, here the billing is done per hour basis for the resource units consumed by the database. So that's the difference between provisioned and serverless provisioning inside of your when you're creating a Cosmos DB. All right. Then after that, you specify. After that, you specify what's called global distribution. Another wonderful thing that you. Like I know I take for granted today because it's available everywhere. Right? you specify your global distribution, right? Are you going to be distributing your database globally? So you specify if you want geo redundancy across the board. Yeah. Of course, I have disabled it. I don't. You want to specify if you're going to have multi-region rights. Remember, Azure regions are separate data centers. Every region is a separate data center. Okay? And then, do you want to have distribution in AZs? Within the region, you've got AZs. So you want to globally distribute it. You want to do multiple region rights. You want to use availability zones and everything in the middle. All right? So depending on what your design or your architecture is, will dictate what you are going to do with it. And then you have the networking piece. Let me share that with you. You have the networking components. So you can specify right over here if you're going to utilize all networks, you're going to utilize a public endpoint or a private endpoint. Right? That's your networking connectivity. Okay, so you can have a Cosmos DB with public endpoints, obviously, so that if you want to connect it from the outside world, you can. You can have a private endpoint only. In my case, I've selected both the private and the public endpoint. Right? And then there is now, for anybody here that has been involved with a backup solution where you are responsible for backups or conducting backups, if you know what I mean, you'll appreciate this, the simplicity with this, right? So right over here, you get to select the backup policy. You can do periodic backup, or for production environments, if you really want to, you can do continuous backups, which means you're never going to lose anything, depending on what you're doing. So I got periodic backups. How long is your backup interval? In minutes, 240 minutes, right? And so every 4 minutes doing a periodic backup. And then how long are you going to retain the information? I'm going to retain it for 8 hours. How many copies do you want to retain? You just specify, and then you specify what your backup storage redundancy is. So basically, if you have to meet some kind of an SLA agreement for compliance, for audit, the fact that you cannot lose information, you know, this whole thing of recovery time objective, right? Recovery point objective, right? Mean time to recover, mean time between failures. You know what I'm saying? The backup information, the stuff that you have to agree to, that you architect, that you build in, and that you provide resources for. You can't just say my recovery point objective is noon. I can't lose more than 4 hours of data. Well, that's great. How are you meeting that SLA? Here, you can just do it. Backup. All right. Then you're also able to select. Encryption if you so choose. Oops. You're also able to select encryption. There you go. That's better. Try that again. Here we are. All right. You can specify if you want to have, if you're going to be using managed keys, or if you want the server to manage it. I want the server to manage it, but you can create your own managed keys, and you can create your own encryption and provide your own encryption if you so want. Okay. And then finally, there is tags, where you create the tag, if you will. Oops. I'll show you that. That's that right there. Yeah, that's that tags right. Oops. That's that tag right there. And I've specified my tagging. Now, I like to specify tagging for everything I do because it is great for billing purposes. I have everything in one place. And finally, I essentially confirm what I want. Okay. Finally, I confirm what I want. I specify that I'm going to create in this resource group, in this location, that's my account name, the API I'm going to be using. I'm doing provision throughput, which means I'm doing it for production. My redundancy is specified right here. I don't have any geo redundancy because this is just for demo purposes, what my backup policy is and what my networks are. All right, and then I create my database, and let me show you what that looks like, right? Let me show you what that looks like. Right? This is what I end up getting when it's all said and done. And then I have to create a container. You see this container right here? Create a new container. I can use an existing container, I can create a new one. So I can specify my database ID. Right here, I've got a demo DB. So I can say, for example, this is going to be demo DB, oops, demo DB2. Okay, I can specify how I want to scale, auto or manual. I leave it automatic. Here's my RUs that I can specify by default. Is 4,000 maximum RUs. So it says your database will automatically scale to 400 RUs, 10% of max, and then it expands it from that point. I can increase these number of RUs based on what the cost is and what I'm agreeing to. Then it's a container ID. What do I want to call the container? I can call it demo container 2. Same thing with indexing. I can specify my partition key. I can specify my partition key as, I can call this thing airport. Okay, my partition key, airport. Notice how it gave me the example. So this is what you do. So my partition key, I can say airport. All right. And then I can choose to enable analytical store. I'm not going to. And I have some advanced options as well. If I wanted to specify partition key if it's larger than 100 bytes, and mine isn't. So airport, and then I just click OK, and it will create that container for me. So here I've got demo DB and a demo container, and this is building one for me right now. Right? You have, I hope you're having fun. So I'm waiting for this thing to get done. So once the container is created, I'm going to upload. Here you go. So this container is created. Okay, this container, demo DB, demo container. Items. I've got no items in here at the moment. Okay, so I can upload an item to this container. All right, so here's what I'm going to do. I'm going to open this up. I'm going to open a, just a second as I grab the container. As I grab my, all right. So I'm going to change this. I'm going to say this is airport JSON manual. So airport ID, San Diego, airport arrivals, manual. Airport file, I don't know. Pick something. Airport runways. Only 2. Save this thing. All right. So I go here and I say upload item, and I click on the upload item, and I go over to Cosmos, and I'm going to go to airport, and right there's our airport JSON. I do an upload, and it created that item. Right. I close this, and I load my case, refresh this thing in my airport. Could have just closed it, but no, I have to do it this way. Give me a second as I bring this up. Okay, here's demo DB, container, items, there's my airport, and there's my San Diego airport. Yeah, I go over to upload item. I go over to my other airport. I'm going to call this one, for example, DFW, right? And big, old, cousins, okay? And then I upload the file, call it airport JSON again, and then I click on upload, and it created that. I close this, I close this, I click on item, reload it, click on this one, and there's DFW. Okay, so that's how I load items. I've got database, I've got container, I've got 2 databases and 2 containers. Okay, right. So database, container. Right. So I can choose to create new containers, and with each database I can construct containers. There's no limit to the number of logical containers I can have. And the logical items that I can have, my logical partitions that I can actually end up having as many rows, if you want to call it that. Remember, these are documents. I can have as many rows as I want to store in these items within a given container. This container over here that I have is stored based on city, see that? And this container over here that I have is storing the items based on airport code. Could be anything if I wanted to. So if you really want to look at how you organize it in a hierarchical way, you choose, you decide, you architect how you want it, and then depending on your geo-replication, depending on how you want it, you can actually scale it out very quickly, however much you want, and then you can back it up, replicate it, store it, access it, whatever you choose to do. Okay. I'll show you something over here. Down here, I have this is what I'm going to show you later. There's this export template option. You see that on the left, bottom left, right? And that generates a template, Azure Resource Manager template. It will generate a template so that I can use that template to be able to build this database, those containers, in any other Azure environment I want. That's the infrastructure as code model, which essentially means that I'm going to be utilizing code template. So this is basically creating the containers. Here's my demo container. See it? Here's my city path. Here's my demo container 2. As you see right there. Here's my airport path. See it? My item, right? The way it's split out. So it will create the database, create the containers, create the items, and basically build the structure for me so I can utilize it immediately. I would be able to download this template right here, and there it is, downloading it, and it's done already. And then once it's downloaded, if I choose to, I can deploy it to some other environment, some other resource group, some other Azure environment, some other account, or I can save it so I know how I built my container, how I built my database, what I called it, where it's stored, and so on and so forth. Okay, so I'm going to get to that in the Azure management side, Azure Resource Manager side. Right? Cool. So that's the Cosmos DB. That's Cosmos DB. Okay, let me show you and talk to you about storage. Storage. Blob storage more specifically. Right? Blob storage more specifically. There we go. So this is something that we all know about, the way you start creating storage. You simply specify in Azure, I can specify storage. Now storage has to start with storage accounts, and you create a storage account. This is the screen that I'm showing you. Right? This is the screen that I'm showing you right here. Okay. So storage accounts. Storage accounts. Storage accounts is where you have your storage created, if you will, your blob storage constructed. You specify which resource group is going to go under, and then you specify the details. Now, region is obvious. You give a unique storage account name that you want to create, and then you specify performance. See, it's standard and premium. Okay, premium is really meant for scenarios that you don't want latency. Standard is meant for scenarios that a little bit of latency is okay. Then there's redundancy. Look at the redundancy here. Look at the redundancy options that exist there. There's locally redundant storage, LRS, which is a low-cost option, which is exactly what I picked. That's a low-cost option for your storage account. Okay, locally redundant storage. Okay. Then there is geo-redundant, immediately failover capabilities. If you select geo-redundant, what ends up happening is it gives you the capability to read even if the site is down. You don't get that capability to read if the site is down. Let me show you what I'm talking about. Otherwise, it seems like I'm speaking in tongues, right? Go over here. Samples store 1 right here. Now notice, look over here. See this geo-redundant? Make read access to data available in the event of regional unavailability. See that? So if I say local redundant storage, I don't have that option. If I select geo-redundant, I do have that option. If I select zone redundant, I don't have that option. If I select geo-zone redundant, I do have that option. So the read access is only there as an option if I choose geo-redundant or geo-zone redundant, okay? So those are the 4 options for the purposes of redundancy, so that you are protected in the event that something goes wrong with that particular region. So I'm not protecting it at all because I placed it locally. Okay, then let me show this to you as I'm looking at this. Okay. You're also able to specify if you want to, this is the advanced storage options. As you click through them, you're able to specify, let me zoom in over here. Zoom in over here because it's too small. So I can choose and say that I want this available for REST API operations. I can enable encryption on the infrastructure side if I want to. I did not. I can enable Blob for public access. I have. Okay. I can say that I can enable storage account key access, and I said yes. Okay. I can default to AD authentication. I did not. You can if you so want. The minimum TLS version that you want to communicate this with. And then there's the data lake storage on Gen 2 that's available. This enables file level access with access control lists, okay, inside of a data lake storage instead of a storage account. And that's really what that's about. As I scroll down over here, move up, this option up. Then, come on. Then I've got blob storage. Look at this. I can choose to enable NFS. From a storage perspective, what storage options do you have in the physical world? You have direct access store, you have network access store, and then you have storage area network, right? The direct access store is the one that allows you to have, right over here, is what gives you hard drive, gives you solid state disks. In the physical world, you get CD, DVD, right? You have access to USB and so on. Okay? Storage area network is what gives you access to iSCSI, yeah, gives you access to fiber channel, and perhaps fiber channel over Ethernet. Yeah, the direct access store and storage area network are both block storage devices, which means that you can boot your machine with those. Okay, that's the difference between direct access store and storage area network. Storage area network is external to the physical device, the physical machine, the physical infrastructure. It is connected utilizing Ethernet or utilizing fiber channel cables or utilizing fiber channel over Ethernet, depending on how you're communicating. SAN devices are great if you want to scale out storage, and I'm not going to get into that at the moment. Okay, but then you have the third option is network attached storage. Okay, the third option is network attached storage, and network attached storage is what gives you your NFS, is what gives you FTP. Okay, is also what gives you this access to this blob store, for example. Okay, so this is telling you that if you want to enable NFS, you can. I did not. NFS has not have been traditionally great with throughput, but because of the backing of Azure storage and the resources you have behind Azure, the networking resources you have behind Azure, you can choose to use NFS v3. Not exactly best if you want to store it this way, but you do get a hierarchical namespace when you do that. NFS network file system, FTP, and such are all considered object store. These are all object store, and object store components, object store type storage is not what you use to boot your data with. You don't boot with NFS. You don't boot with FTP. You don't boot with a blob. You connect to it, you access it, you store data on it, you retrieve data from it, but you don't boot from it. Okay? You boot from a direct attached storage, your solid state disk, your hard drive, your CD DVD, your USB, your floppy, if you use floppy still. You can boot with SAN devices as well. There's something called boot from SAN. So you can boot from SAN devices as well. You do not boot from a NAS device. Okay, so blob storage is object level object store, and object store essentially allows you to save data. Okay, and then you can have cross-tenant replication if you so want. And then what access tier you have? You can have a hot or cool access tier, right? Have data ready to be used immediately. Or you can have cool, which means infrequently accessed data, and maybe in backup scenarios. Every kind of data that you store inside of a blob doesn't need to be accessed immediately. You get to specify how you want it, and you're going to be charged accordingly. If you choose cool, you're going to be charged to write the data to that cool store. Okay? If you choose hot, you're going to be charged to read the data from wherever you're reading it. You know what I'm saying? The dependency on the pricing model, architecture, and design model is different depending on what you pick. And then there are Azure large. You can enable large files. You can store large files that are in gigs and terabytes if you so want. Okay, and then you can enable queues. You can enable tables and queues if you want inside of that as well. All right, let's go over here to, when you create a storage account, you get to specify if you want a public endpoint, right? Or do you want all networks or selected network? You get to specify that, or a private endpoint. You don't want it to be accessed from everywhere. Do you want to use Microsoft routing or do you want to use internet routing? You get to pick by default. Microsoft routing, Microsoft network routing internally is what's picked for optimization. Okay. Then you get to also pick, come on, when you're creating the account, you get to specify the protection, data protection. Okay, so you can specify point in time restore for containers in the storage account terms, storage account and containers in storage account terms are similar to folders. Okay, they're similar to folders. So a data container within a storage account would be the data folder. All right, a test or work or my code or my application would all be folders. All right, and then you can specify if you want to allow soft deletes for blobs or containers. Blobs essentially is items within that container, files within that container. Okay, you want to enable soft delete for file shares, and then how do you want to track? You want to track versions, you want to track changes, depending on what you're storing in there. Changes and version control may be something you need. Again, depends on how your storage has been created and how your storage has been designed and what purpose it's going to be used for. And then finally, there's the tagging piece where you specify the tag, and I did specify a tag, and I'll show you. Okay, I've got a tag down here. I've got a tag right there, storage demo tag. These are what I specified, and then I created the storage account. Let me go over here and show you the storage account. Go there, and there's my Rafik store, okay, and my container within the store. And if I create, so here's I've got a container called Python code. I'm going to create a container, and I'm going to call the container DB items like that. And I'm going to make it, I'm going to allow anonymous access. It's giving me a warning saying, hey, are you sure you really want anonymous access in this container? I'm just going to say yes, because I'm a nice guy. Just let everybody in. So here's my Python code, and here's my DB item. Click on DB items, right? And then I'm going to do a upload. and I'm going to upload to DB items. I'm going to upload my airport JSON file. Upload that airport JSON file. There you go. That's just an item. So I loaded a file in a container, file in a folder. Item in a container is a file in a folder, okay? Item in a container is a file in a folder. The name of my item is airport JSON, and the name of my container is essentially what I constructed called DB items, as you can see on the top left. Okay. Now, once I've uploaded this, I can click right here and I can choose to download it, view it, and edit it if you want. I can also generate what's called shared access key, SAS. Now, shared access key gives me the ability to create a URL temporarily. Let me show you what I'm talking about. So I'm going to say that from 1204 to 1206, okay, I'm going to make this available. I'm going to say generate a key. And there's my access key. Right there's my access key. Now, this access key is for this airport JSON file. If I paste the access key, let me copy it, paste it, and there's my file right there. That's what I've given access to. Okay, so that's the shared access key, giving URL access to a given item. You can share the whole container if you so want, but it's not something I'm doing right now. Okay, you can also create a snapshot. You can view snapshots that you have with the container, and so on. All right, so that's storage, right? Storage. Okay. The next thing I'm going to do is I'm going to show you what I do here. Storage accounts. I'm going to go over to Rafik Store, and here's my. See this export template? Export template, and it's generating a template. Here's my template. So I'm going to copy this template. I'm going to show you something. Copy this template, and I'm going to open Notepad, although it's not the greatest tool in the world. Paste this template in there. Now the thing is, I could. Let's change a font. I can use VS Code for this, obviously. I can use Visual Studio for this, but here's my container. So if I do Rafik Store 22. Storage demo 22. I'm just specifying a different name, creating a template on the fly. And as I go down, I'm going to make sure that I've got some specifications in my case that apply to a unique creation. So this is my template. This is my template, Rafik Store name, container. You go up there. Save this, and I'm going to say here, storage ARM. Okay. Now, if I go over to up here and I say deployment, so you just deploy, I'm going to deploy a custom template. This is deploying ARM templates. I downloaded the ARM template. I downloaded the template. You can create it from scratch too if you want. And I'm going to go over here and I'm going to say deployment, deploy custom template. And then I'm going to say, all right, I'm going to go ahead and I'm going to create my own template. I'm going to essentially build my own template. I'm going to grab that, paste that. That's my own custom template. Let me go back over here, grab my template, where I'd labeled it Rafik 22 right here. See that? Store demo 22 right there. Yeah, my unique template. And then every other specification that I had that I specified, right? And then I'm going to save the template right there. And look, it fills it in. See that? It fills it in. If I go to review create right here, I just click on create and it will create that store. It will create the under that account. It'll create my container, everything the way I have it in my store. ARM template. Deploying an ARM template by simply specifying that I want to deploy right here, I can deploy a custom template. And when I deploy a custom template, I specify what kind of template I want to store. And let me click home over here. I'm going to do deploy, just so that you're sure, deploy a custom template. Specify, build my own template in the editor. I basically replaced this with the template that I downloaded, changed a few things, These are variables that I can actually grab, and I can store my own variables, and I can store my own values, and then I can use parameters, as you can see, that will reflect whatever variables I want to store, making that template, making that ARM template unique. Okay, so what did I do? What did I do? I wanted to let you know, and I wanted to talk to you about Cosmos DB, the NoSQL solution inside of Azure. I wanted to talk to you about blob storage and what that is and how it works. And then I wanted to show you ARM templates in a very quick way, so you could see how you can export existing templates out and you can deploy the templates utilizing Azure. Really, really glad you were here. Do you have any questions for me that I can help answer about the three things that I've been covering? I've been yapping for so long. Yeah.
There's one question about the global distribution itself for backup and failover with Cosmos DB. The question is, does this backup setting apply for each replication, like backup done in region 1 and region 2?
Yeah, so it applies to each region. Yes, it does apply to every region that you're doing a backup for. Yes.
Wonderful. Hopefully that answered the question. Thank you.
Mm-hmm.
That's the only remaining question I think we have. I think we addressed all the other questions.
I love this. My excitement didn't come through, did it? I'm so glad you guys are all here. Really? That's it? Nobody else? Did you guys have a good time? Here's some things about Cosmos DB, about Azure solutions, about storage, about ARM templates, the simplicity with which they can be created and worked on, right? I really hope you learned a few things that you can take back with you.
Thank you, Rafiq. Really appreciate you
Thank
teaching us today on all of that. For any of you that want to join him tomorrow for part 3 of our Azure for AWS webcast series, he'll be going over implementing API management and develop event-based solutions. I did drop the link where you can register for that and the remaining sessions that he's going to be leading both on Thursday and Friday. So very, very unique, very, very unique event series. So we hope that you can join us for the rest of the week as well too. The recording will be available to you within the next 2 to 3 business days. You'll receive an email with that. But again, we'd love to be able to see you live here in the next few days, where Rafiq is going to be joining us throughout this week. So thanks again, everyone. If you have any further questions, feel free to send those your way. Again, we hope to see you later this week.
Thank you so much.
Take care, everyone. Thank you.
Bye.